Can I get a hey, hey, ho, ho? 3.5, graphing linear inequalities in two variables. All right, cool. Now, what some of you might be thinking is, we already know how to graph linear inequalities. We put them on a number line, and that's how we do it. But what we're looking at today is graphing in two variables, so using x and y. So not just taking one variable, putting it on a number line, and saying that's it, but instead graphing it on a coordinate plane. So we can write these in a ton of different ways. What I have here is standard form, and all of these ax plus by equals c is what we're used to seeing. But we can basically replace that equal sign with less than or equal to, greater than or equal to. And what we notice is that the solution of a linear inequality in two variables is an ordered pair. My delightful handwriting there. Ordered pair, x and y, that make the inequality true. So I could put in an x value, I could put in a y value, and that would mean that the inequality came out true. Basically the same definition as a linear equation, with the exception that now instead of looking at equality, we're looking with inequality signs. So nothing really has changed. So in the first example, all we're doing is checking to see if a specific ordered pair actually is a solution of the inequality. How do we do that? Well, if it's a solution, it makes the inequality true. So I should be able to say 2 times negative 1, which is our x value, plus y, which is our 9, which is a 9, and that should be less than negative 3. So 2 times negative 1, that gets you negative 2, plus our y value, which was 9, is that less than negative 3? Negative 2 plus 9, that should be positive 7. Is 7 less than negative 3? I don't think so. Doesn't work. Now let's look at part B. I have x minus 3y greater than or equal to 8. Is 2, negative 2 a solution to that? Well, let's try it out. 2 is my x value, so I can put that in there for x, minus 3y, y is negative 2. Put that in there, greater than or equal to 8. Alrighty, let's do 3 times negative 2, or technically negative 3 times negative 2, so that becomes positive 6. 2 comes down, greater than or equal to 8. 2 plus 6 is 8. Greater than or equal to 8. Well, is 8 greater than or equal to 8? It's a good thing that or equal to is in there, because that means it's true. 8 is equal to 8. Beautiful. So two examples here, one where it does not work, one where it does work, and it is a solution. Alrighty, let's move on up. The graph, try to write that a little more neatly for you. The graph of a linear inequality in two variables shows all of the solutions. Of the inequality in a coordinate plane. So it's not just going to show me, okay, 2, negative 2 is a solution to this one. It's going to show me every single possibility for solutions. Alrighty. How do we graph linear inequalities in two variables? First, what we're going to do is graph for the boundary line. Now, what do I mean by boundary line? That basically means I want to graph it as if it's a linear equation. So if I have something like this example up here, 2x plus y less than negative 3, I want to pretend for a second that that says 2x plus y equals negative 3. And that we know how to graph. Okay? Then what I want to do is use a dashed line. And this is where it gets different. Use a dashed line for less than or greater than, and use a solid line, just like for a regular linear equation, if it is less than or equal to or greater than or equal to. Okay, so that's the first difference. I graph it the same way and I put the line in the same place, but it could be a dashed line if there's no or equal to, and it could be a solid line if there is equal to. Then what I need to do is choose a test point. And what a test point is something, a single point on the coordinate plane that is not on the boundary line. Okay, and what that's going to do is it's going to determine which side of the line contains all of my solutions. Okay, if the test point is a solution, then you want to shade the half of the plane that contains the point. If it's not a solution, you shade the other half. So let's take a look at what all of this means in context. Okay, first thing I want to do is graph y is less than or equal to 2 in a coordinate plane. Okay, that seems easy enough. So let's think about it first in terms of a linear equation, y equals 2. Well, I know that y equals 2 is a horizontal line, and I know that horizontal line is going to be at 2. So, horizontal line, that could have been more straight, but we'll let it go. Now, what I have to do is I need to choose a test point. The test point can be anywhere on this coordinate grid, as long as it's not actually on the line. So I'm going to choose the point, let's just say 2, 4. That's going to be my test point right up here. And then I'm going to ask, is that test point a solution? So the point 2, 4. And I'm going to plug it in. My y value is a 4. Is 4 less than or equal to 2? No, it's not. 4 is greater than 2. So this test point is not a solution. What does that tell me? It tells me that my actual solutions to the graph are all down here. And what else do I have here? I have a solid line going across because this said less than or equal to. Because of the equal to, I put a solid line. The difference is going to be shown in part B when I have something like x is greater than 1. When I think about just the graph of x equals 1, it's a vertical line at 1. So I'm going to just do a vertical line right down here at 1. That's my x equals 1. But this inequality tells me that its x is greater than 1. So there's no equality there, which means I actually need to make that a dashed line. Let me make these a little bit bigger. Dash, 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 dash. Should be a dotted line. Very good. Now I need to make a test point. I'm going to choose, let's say, this point right here. It's going to be 3, 2. Alright, so I'm going to put in 3, 2. And I check it. 3, 2. X value is 3. 3 goes into here. 3 greater than 1? Absolutely is. So my test point is a solution. So that means that I shade this side where the test point is. And that is my linear inequality graph right there. Now let's look at one that's a little bit harder. One that's written like standard form. So the first thing that we want to do is try to pick out some important information from the graph. That way we can actually graph it as if it's a linear equation. So how can I basically rewrite this equation so that it looks like it is in slope-intercept form? Well, slope-intercept form means that I have y by itself. So if I want to get y by itself, I need to add x to both sides, and then I need to divide by 2. So if I do that, add x, and add x, I get 2y is greater than 2 plus x. And then I divide by 2 on both sides, and I'll get y is greater than 1/2 x plus 1. And now that I have it this way, it's a lot easier for me to see what important information there is. For example, this number right here is our slope. Our slope is 1/2. The y-intercept is right here. It's a 1. And now I need to just worry about graphing it. What's my start point going to be? My start point is going to be the y-intercept, 0, 1, right there. Now, once I have my start point, all I have to do is go up or down, left or right, however many the slope tells me to do. So I'm going to go up 1, because the slope is 1, over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. And I can do the same thing in the other direction. Then I connect the lines, back to black here. And that is my linear equation graphed. But now I need to think about, is it a solid line or is it a dotted line? Well, based on my equation here, I don't have any equals. So that means that I need to break this up. This should be a dotted line. Alrighty. Now I need to figure out what side gets shaded. Okie dokie. I got to make a test point. Let's try the point right here. Ooh, that's not a very clear point. I wanted that one. The point 2, 0. Okay, so is 2, 0 a solution to this equation? Let's put it in here. My x is going to be a 2, so that goes right here. My y is a 0. So when I have, I'll write it down here. I'm going to have a 0 for my y, 0 greater than 1 over 2 times 2 plus 1. So 1/2 times 2 is just 1, and then plus 1. Is 1 plus 1 less than 0? No, it is not. So that side of the equation is not shaded. The other side is. So my shading comes up here. Cool. I think that's it for this one. Alrighty, everybody. Make sure you do the assigned problems. Write down any questions that you need to ask me, and we will talk again next class.